All right, good morning. Today we're going to be going over a bunch of vocabulary and getting ready for our next activity, which involves us being able to draw a bunch of different shapes. So let's go on and get started. So first off, we need to understand some terms that are involved in computer science. So when you hear these terms, you should automatically know what they mean. The first thing we want to talk about is what a program is, right? And a program is simply a set of instructions, right? It's a set of instructions that comply with specific rules of a programming language. And what they do is they perform a particular task with the computer, right? So hold on, let's open this. Let's open this real quick. Sorry. Let's open the document. Oh, I gotta verify all this stuff. Sorry. Boom. Here we go. So I could just type it out for you guys real quick. Um, Boom. So program. All right, program. It is a sequence of instructions that comply with the rules of a specific language, specific programming language, sorry, specific programming language, and it is written to perform a task with a computer. So examples, right? A video game, right? A video game is a program, right? The video game does not operate unless I put it into the system or unless I download it to the system in which that system has this language that connects with the video game. So now the video game can be read by the computer, and now you can do whatever you choose to do with that video game. Hence why I can't take a Xbox video game and play it on a PlayStation 4, right? There are two different programming languages. So if I put the Xbox game on the PlayStation 4, it doesn't read. It does not understand the language, right? Does not understand the program. So, does not understand the instructions because it isn't programmed or it hasn't been written to connect with that computer. So a program is simply a sequence of instructions that comply with the rules of a specific program language and is written to perform a task with the computer. You need the instructions and you need the program to interact with those instructions for it to work. So that's the first thing I want to get out. So now let's look at the second portion, which is just as important, is an algorithm. And we already started building algorithms. You probably didn't notice it. Of course, you didn't notice it because you haven't heard the terminology, but we did this yesterday. So this should look familiar to you guys. I'm going to go ahead and put this together real quick. Set pen color, pen down. Then we're going to go motion, 10, block 90. So I'm going to go ahead and copy this duplicate this 4 times. Duplicate. I'm going to change these size real quick. I'm missing one move. All right. And so when I press this space bar, I draw this object, which is a square, right? This entire process right here, this right here, this that I'm circling right here, this is what we call an algorithm. This is what we call an algorithm. Now, what is an algorithm? An algorithm is a self-contained, step-by-step set of instructions to solve a specific problem or class of problems. Again, It is a self-contained step-by-step set of instructions to solve a specific problem or class of problems. Right? So in this situation, what we were trying to do is we wanted to draw a square. And so we created, and so our problem was, how do we draw a square? How do we draw a square? And we created an algorithm to solve that problem. Hence, move 25, turn 90 degrees, move 25, turn 90 degrees, move 25, turn 90 degrees, and move 25, right? That allowed me to then draw this square right here, or this allowed me to build a square. In order for me to draw it, how do I get it on the paper? We had to solve that other problem, which was creating a pen color that's visible on the canvas and making sure that the pen is down so that now we can see it on the canvas, right? So essentially I could break this down into a series or a class of problems, hence two problems right here, which is what I did. First, how do I visually see the square? How do I now draw the square or create the square? Or most of us will just look at it as one issue, making a square. So, algorithm. A self-contained step-by-step set of instructions that is used to solve a problem, a specific problem, or a class of problems. All right, it's important to understand that when we are building something, when we're building something in computer science, we look at it from a problem-oriented lens. What does that mean? That means that in order for me to create something unique or exciting or wonderful, I need to look at it from the aspect of what is it that I need to do to build it. I need to break it down into small pieces and put it together, right? So, when they make, for example, when they build a building, when they put a building together, they don't just go and look at the land and say, okay, we're gonna put the building right here, right, and just start building stuff up, right? They create a blueprint, right? They go and measure. So they say, hey, you know what? I got the space that I have is 400 by 400 feet. I need to have 3 rooms. So what's the size of one room? One room is going to be 200 by 200 feet. Another room is going to be 100 by 100 feet. Another room is going to be 50 by 50 feet. Okay, I need to have a bathroom over here. I need to have this over here. They break it down into all these different parts, right? And then they solve those parts first before they put everything together, right? They solve those parts first. And then when they run it, it all comes together, right? So that program, right? And those algorithms, each part is a particular algorithm, right? When we look at a house, a three bedroom house per se, each bedroom is an algorithm. The kitchen itself is an algorithm. The bathroom itself is an algorithm. The living room itself is an algorithm, right? And then that all comes together, right? That all comes together and we run it, right? When we put all that together, we built the house, right? Which could be called a function, right? So that could be called a function, right? The function is the implementation of an algorithm or multiple algorithms, right? And the reason I say that is because a function can call an algorithm to run or it can call multiple algorithms. You'll see that when you start building functions, when we build these functions will do multiple tasks. They will call multiple algorithms sometimes, right? So you can have a simple function that does this right here, right? So this right here is our algorithm, but if we title this, we can title this a square. We're going to actually get into that later. I'm going to show you that later, not right now. But we can title this thing right here a square, and we could call it function square. And every time we click on that button function square, it runs this algorithm, right? It calls this algorithm and says, hey, build a square, right? That's what it is, build a square, right? We can create one that says function house, right? And inside of function house, we can have uh, the algorithm for bedroom 1, the algorithm for bedroom 2, the algorithm for bedroom 3, the algorithm for a kitchen, algorithm for a bathroom, algorithm for a living room, right? And all those in there, all those algorithms could also be functions themselves, right? So we could call that function bedroom 1, function bedroom 2, function bedroom 3, uh, function living room, function kitchen, function bathroom, right? We can do that as well, and then have one function called function house call all those functions together. So that is really important. Now, what I am going to show you is going to be really, really useful for this activity that you're getting ready to do. So, as I showed you guys, we're already able to draw a square. Now, there is a easier way to do this, right? As we can see, we have this move 25, turn 90, move 25, turn 90, move 25, turn 90, move 25. What is happening here? This code is consistently being repeated over and over and over, right? As I said, steps, right? So these steps are consistently being repeated. Whenever we have steps that are being repeated consistently, we can do things such as use a repeat button. This repeat button is also called a loop, right? So in code, we call this a loop, right? And what is a loop? A loop is a sequence of instructions that repeats itself over and over until a condition is met. So, what does that mean? Well, I'm looking at this right here. Oh, you know what? I can run this 10 times if I wanted to, right? If I run this 10 times, it ends up drawing a bunch of squares, right? Go ahead and move this so you guys can see it. Watch this. All right, I end up drawing 4 different squares if I repeat this. I don't want to draw 4 squares. All right, I want to draw 1 square. Right? So what I could do is I could take this code and simplify it by looking at it and say, hey, what is the action that's consistently happening over and over and over? Well, I'm moving it and it's turning, right? So I'm going to take the rest of this out. And I know it's going to move. I know it's going to turn. Let me go ahead and clear my canvas real quick. So I clear my canvas. And I'm going to move my sprite back to its 0, 0. And let me turn it back around. All right, cool. So I want to move it and I want to turn it. Now, I know that I'm going to be building a square. So how many sides does a square have? The square has 4 sides. So I know that it's going to move 4 times because I need 4 lines, right? And I know that a square has, each side has a 90-degree angle. So that means it's going to have to turn 4 times at the 90-degree angle. So instead of me writing this over and over and over 4 separate times, move, turn, move, turn, move, turn, move, turn, I can just go here and push this repeat. And I can say, hey, repeat this same step 4 times. So I go ahead and repeat it. And now I have a square. So instead of me writing all that code that I had previously, which was this, and I'll put it to the side so you can see it. Let's duplicate, duplicate. Instead of writing all this right here, all that right there, all this right here, is equivalent to this information right here. Again, all this right here is equivalent to this right here. Very, very easy, right? So now that you have this, you're going to be doing, you can use this tool, this repeat or this loop, right, to help you build other shapes. Now, it is important that you understand that if there If there's commonalities, I mean, if I'm doing the same action over and over and over, applying a loop is going to be pretty easy. But what if there's some variations? I might have to become creative with using my loop. All right, that's the hint for you. You guys enjoy the activity.